Before a software is released to market for commercial use, it undergoes rigorous testing. But if you had to answer the question, what is software testing? What would you say? It is something that's pretty difficult to compress into a couple of short sentences. And there are also a lot of misconceptions about what software testing is and what testers do, even among testers themselves. Testing as a skill and as an industry is constantly evolving. Hey guys, this is Archana from Edureka, and I welcome you all to this session on software testing. Well, in this session, we'll seek to look at some of the things of what software testing is and isn't. But before we begin, let's quickly go through today's agenda. We will begin this session by discussing certain things about software risks, and then we'll get started with our today's topic, which is software testing. We will learn what software testing is, benefits of using software testing, principles of software testing, and the most important thing, software testing lifecycle. We will also discuss certain concepts related to dynamic software testing and finally conclude this session by having a brief discussion on what future of software testing would look like. Well, I hope agenda was clear to you guys. Let's get started then. Software is a highly complex thing. It depends on code that is written and maintained by others and in different locations that may be across the globe, cutting across entirely different programming languages, techniques, servers, networks, and many other things. Bugs, therefore, are an unfortunate reality for every software product. And there are a lot of risks involved in software. By risk, I just mean anything that can potentially cause a loss of something of value. This can include functional issues, or it can be scalability issues, reliability issues, security issues, or performance issues, or any other thing. Unfortunately, sometimes these issues manifest into software disasters and have caused millions of dollars in waste and sometimes even led to casualties. For example, Starbucks coffee shop was forced to give away free drinks just because of a register malfunction. A F-35 military aircraft was unable to detect the targets correctly because of a radar failure. A high voltage power line in northern Ohio, it brushed against some overgrown trees and it was shut down. Normally the problem would have tripped an alarm in control room, but due to software issues the alarm system failed. And that day there was like power cut for about 24 hours in the entire city. Similarly, in 1985, Canada's Therac 25 radiation therapy machine, it malfunctioned due to some software bug and it delivered lethal radiation to patients, like leaving 3 people dead and critically injuring many others. Well, I can keep going. Software failures happen every day. You've probably experienced a software failure in the past week or even days. As simple as an app glitch on your smartphone to serious ones like cancelled flights or crashing infrastructure systems and many others. Software bugs have become so common to everyone's lives that it would be easy to simply just roll our eyes and say, hey, here we go again. But what if software professionals do that? How do companies make sure that disasters won't happen? Well, software testing. Software testing helps to find bugs. Well, if I have to define software testing, it is quality analysis of software code to understand if the software performs as expected or not, and to learn about ways in which it can be improved. Suppose you entered a baking contest and you're planning to make cookies. Chances are you will first make a small batch of cookies to test how good your recipe is and if everything tastes well and fine as you expected it to be. Well, depending on the feedback you receive about the taste and other qualities of the cookie, you would then modify your recipe and proceed for further cooking. Software testing is somewhat similar in that sense. Well, after a programmer or a team of programmers write a software program, there are information technology professionals known as testers who would then test the software to see if there are any areas where the software crashes or does not yield the results as expected. That's what software testing is all about. Well, the main objective of software testing include to verify and validate the completeness of the software product, to check if the software product meets the business and technical requirements, to identify technical bugs and to ensure that the software product is glitch-free in the end or before it's released to market. And lastly, to generate high-quality test cases and issue correct problem reports. Well, I'm sure at this point you're clear of what software testing is, right? But why do you think we need software testing? What benefits does it offer to any of us? First of all, it gives confidence in the quality of the final product for the organization producing the software product. It saves a lot of time, effort, and money for the organizations that are developing and selling the product. Because once the product is tested, they can be sure that there are no faults that would prove fatal to them or the company later on. It even offers business optimization. It confirms that an application is able to operate well and fine in all required conditions and on all different kinds of operating systems or web browsers correctly and properly. Well, this enhances user experience and customer satisfaction. Lastly, obviously all these factors contribute to money, so they bring profit to organization. In simple terms, in order to make sure that the release software is safe and it's functioning as expected, the concept of software testing was introduced. It's paramount important because software bugs, errors, defects can potentially lead to expensive or dangerous consequences in the software program, like the few of them which I mentioned earlier in the session. So the software testing is an exceptionally imaginative and an intellectual task for testers to perform. Testing of software or application consists of some principles that play a significant role for a software tester while testing the project. What I mean is there are a certain set of principles that every tester should be aware of when they're performing software testing. So what are the basic principles of software testing? Let's discuss that. First of all, software testing can help in detecting bugs. That's the basic of it, right? Testing any software or an application can help in revealing a few or some defects that may or may not be detected by developers when they develop the product. However, testing of software alone cannot confirm that your developed product or software is bug-free or error-free. Hence, it's essential to devise test cases and find out as many defects and errors as possible. So the first point or the principle here is software testing can help in detecting bugs if you have proper test cases and test scenarios. The next principle is that exhaustive testing is impossible. Well, there's no way to test all combination of data inputs, scenarios, and preconditions within an application. For example, if a single application screen contains about 10 input fields with 3 possible values, this means if you have to cover all the combinations, then you would have to create about 59,049, I guess, test scenarios. Well, that doesn't look good, and it's just for one app screen. Imagine you having 50 plus such screens. Well, in order not to spend weeks creating millions of such less possible scenarios, it's better to focus on potentially more significant test cases. The third principle is you should perform testing as early as possible. The cost of an error grows exponentially throughout the stages of software testing lifecycle. Therefore, it is important to start testing the software as soon as possible so that all the detected issues are resolved and they do not affect you later on. Next up, we have defect clustering. Well, according to a certain principle, approximately 80% of all errors are usually found in only 20% of the system modules. Therefore, if a defect is found in a particular module of the software program, the chances are that there might be other defects as well. That is why it makes sense to test that area of the product more thoroughly. And testing is context dependent. Depending on the purpose or the industry, different applications should be tested differently, right? While safety could be of primary importance for a fine tech product, it is less important for a corporate website. Well, the latter, as in the corporate website, in turn puts an emphasis on usability and speed. So according to your situation and requirements, you should choose what type of testing you want to perform. And lastly, error-free or bug-free software is just a myth. The complete absence of errors in your product does not necessarily mean that your testing was successful. No matter how much time you have spent polishing your code or improving the functionality of your product, if it's not useful or it does not meet the user expectations, it won't be adapted by the target audience or it can't be released to market. It's as simple as that. So these are certain basic principles of software testing. Well, along with the principles we discussed just now, you might have to consider some additional sources to note other principles in addition to the basic ones. With that said, the next topic that we're going to discuss here is very important concept in software testing, which is software testing lifecycle. So what exactly is software testing lifecycle? Organizing a software testing process can be quite challenging. Just like how developing a software involves a sequence of steps, Testing also involves steps that can be executed in a definite sequence. This manner of executing testing in a systematic and planned way is what we call a software testing lifecycle, or STLC. Basically, it comprises of 6 phases, which include requirement analysis, test planning, test case development, environment setup, test execution, and test cycle closure. Well, I'm not going deep in here, but let's just discuss what each of these phases mean in software testing lifecycle. So the very first step in software testing lifecycle is requirement analysis. In this stage, the testing or the QA team decides what needs to be tested. There are two kinds of testing mainly, functional and non-functional. We'll talk more about that later on. Functional testing includes tests to evaluate how the software is functioning, and non-functional testing includes features that are behind the scenes such as performance, security, and all that concepts. So the team here considered both functional as well as non-functional requirements into consideration. Well, after a decision is made as to what aspects of testing need to be completed, the next stage is planning how the test will actually be conducted. This includes deciding the resources in terms of cost, the number of personnel that should be assigned to the testing phase, the number of hours it should take, the deadlines by which the result should be delivered, and many other things. Basically, you're planning the entire test process in this step, and there's something called a test plan document, which involves your entire plan from the first step to the last step. If you want to know more about what test plan is and how do you write a test plan, its pattern and parameters involved in that, well, there is a video called How to Generate or Create a Test Plan in Edureka software testing playlist. So please do refer to that. So the second step is basically planning everything as to how to perform, when to perform, and all that. Next up, we have test case development. One of the important stages of software testing lifecycle is developing the test cases. This includes writing out a step-by-step procedure on how tests should be executed, the expected results, the actual results, and if the test was a pass or a fail. And again, if you want to know more about test cases and how to write a best test case, well, you could refer to How to Write a Test Case video in Edureka YouTube playlist. So coming back, test case development is a really important concept, and you have to consider many different things here when you're actually generating a test case. The fourth step is environment setup. So before the actual testing can be started, the test environment has to be set up. A testing environment is a setup of software and hardware for testing teams to execute test cases in comfortable manner. It supports test execution with hardware, software, and network configurations. Next is nothing but test execution. The next phase is the process of executing the code and comparing the expected and the actual results. When test execution begins, the test analysis starts executing the test scripts based on the strategy which you have selected for your project. Lastly, it's test cycle closure. It involves calling out the testing team members for meeting and evaluating complete cycle criteria based on test coverage, quality, cost, time, and many other concepts. So basically here you're analyzing the test result reports and seeing how you can make them better or how you can improve them, or discussing the results, organizing, and basically discussing the entire testing lifecycle is the last step, which is test cycle closure. So these are the 6 most important phases of a software testing lifecycle. Well, when you are setting up testing environment, there are certain things that you should be aware of. First thing is that software testing is broadly classified into 2 categories, static testing and dynamic testing. Static testing initially checks the source code and software project documents to catch and prevent defects early in the software testing lifecycle. It's also called non-exhaustive technique and verification testing. It could be performed as inspections, informal and technical reviews, or it could be reviews during walkthrough meetings that you organize with team members and all that. So basically, it's an informal form of testing. But as soon as the primary preparations are finished, the team proceeds with dynamic testing, where software is tested during execution. Dynamic testing can be described by different methods, levels, and types of underlying quality analyst activities. Let's have a closer look at this segment of dynamic testing process. So first up, we have something called software testing methods. Software testing methods are nothing but the ways the tests are conducted in real. They include black box testing, white box testing, gray box testing, and ad hoc testing. So black box testing, I'm sure you might have heard of it before. It gets its name because a QA engineer here focuses on the inputs and the expected outputs without knowing how the application actually works internally and how these inputs are being processed. The purpose of this black box testing is to check the functionality of the software and making sure that it works correctly and it's meeting user demands. Next up, white box testing. Unlike black box testing, this method requires profound knowledge of the code as it involves testing of some of the structural part of the application. Therefore, generally, the developers here are directly involved in writing code, are responsible for this type of testing. The main purpose here is to enhance security, the basic flow of input-output throughout the application, and to improve the design and the usability of the product. Well, obviously, there's a combination of both black box and white box testing. That's what we call a gray box testing. It involves testing of both functional and structural part of application. So using this method, an experienced tester has partial knowledge of internal application structure, and based on this knowledge, he can design test cases while still pursuing the black box perspective. Apart from these, we also have something called ad hoc testing. This is an informal testing method as it's performed without any planning or documentation. Conducting tests informally and randomly without any formal expected results, the tester improves the steps and without even knowing executes them here. So basically in ad hoc testing, there's no documentation, no test design, no test case, no planning. So each of these methods that we discussed just now, I mean the white box, black box, and ad hoc testing, we have multiple techniques coming under these categories. For example, under white box, you have statement coverage, decision coverage, condition coverage, and multiple condition coverage. For black box testing, you have decision tables, use case testing, state transition diagram, BVA, which is nothing but boundary value analysis, equivalence partition, and under ad hoc testing, we have pair testing, monkey testing, buddy testing, and much more. If you want to know more about any of these techniques, you can refer to the software testing methodologies and techniques video or blog in Edureka playlist. So next up, we have software testing levels. A piece of software is more than several lines of code. It is usually a multi-layer, complex system incorporating dozens of separate functional components and third-party integrations. Therefore, efficient software testing should go far beyond just finding errors in the source code. There are 4 main levels of software testing: unit testing, integration testing, system testing, and acceptance testing. Let's briefly check out what each of these levels are. So the first level of unit testing is the micro level of testing. It involves testing individual modules or a piece of code to make sure each part, or I can say unit, is working properly. Here, when I say unit, it can be a specific piece of functionality or a program or a particular procedure within an application, or it can be anything. It depends on what the tester considers a unit is. Unit testing helps verify internal design, internal logic, internal parts, as well as error handling. So after unit testing, integration testing is performed. This level tests how the units work together. Individual modules are combined and tested as a group. It's one thing if every unit of your software project is working well on their own, but how do you think they'll perform together? Well, integration testing helps you determine that and ensures that your application runs very efficiently. It identifies interface issues between modules. Well, there are a few techniques that can be used here. We have Big Bang technique, top-down approach, bottom-up approach, and many other things. To know more, you can refer to the integration testing video on the software testing Edureka playlist. The next level of testing is system testing. As name implies, all the components of software are tested as a whole in order to ensure that the overall product meets the requirements specified. System testing is particularly important because it verifies the technical, functional, and the business requirements of the software. Final level of testing is acceptance testing, or sometimes it's referred to as user acceptance testing or UAT. It determines whether or not the software is ready to be released to the market. Let's face it, guys, requirement keeps changing throughout the development process, right? And it's important that user verifies the business needs are met before the software is released into market for commercial use. So that's what UAT or user acceptance testing, the fourth one, is all about. So each level of testing has a particular purpose and it provides value to the software testing lifecycle. Some levels are on their own type of testing, for example, unit testing. But some have certain categories under them, like integration testing, like we discussed, has Big Bang approach, top-down approach, bottom-up approach, and like that. Lastly, we have software testing types. So basically, these types are approaches and the techniques that are applied at given level, like we discussed the different level, using an appropriate method to address the requirements in most sufficient manner. Well, like I said earlier, the purpose of testing and the testing tool or the strategy that you use every time keeps changing depending on the requirements, right? And that we call different types of software testing. There are a variety of software testing types, and each of them serve different purpose. So broadly, it's divided into functional testing and non-functional testing. Under functional, we have unit testing, integration testing, system testing, interface testing, smoke, sanity testing, and many others. Coming to non-functional testing, we have performance testing, security, reliability, and many other things. So each of these testing types that you can see on the screen have their own purpose and the importance. Based on the requirements of your testing, you should choose the one which suits your category. So guys, this brings us to the end of the session. And finally, I have a question for you guys. How do you think the future of software testing will be? Well, if you ask me, as a part of technological progress, testing is continuously evolving to meet ever-changing business needs as it adopts to new tools that allow tester to push the boundaries of quality assurance. Well, new technologies that are expected to affect software testing in near future are security, artificial intelligence, and big data. Well, that's my opinion. If you have anything to say regarding the concept, you can go ahead and put them in the comment section below. We are open to suggestions. And if you have any doubts or queries regarding the session, please do put them in the comment section as well. Thank you guys